The quietest hours are always a warning. To understand the sheer violence unfolding on the Big Island of Hawaii, you have to look 2,000 kilometers below the Pacific seafloor. There is a thermal anomaly anchored to the boundary of the Earth's core. It is a stationary mantle plume, a relentless subterranean blowtorch. Above it, the Pacific plate is grinding northwest at a tectonic pace of 7 centimeters a year. The plate moves, the blowtorch stays. That friction is the biological heartbeat of the Hawaiian Islands. Heat melts, the rock punches through the ocean floor and builds land from nothing. Today, that ancient conveyor belt has, for over a year, Halemaumau has locked itself into a highly specific metronomic rhythm. Following a year-long pause in activity, a new episodic eruptive cycle began on the 23rd of December 2024. It established the longest sustained pattern of summit lava fountaining at Kīlauea in over a century. By early May 2026, we had already tracked 45 distinct fountaining events. That translates to an average of 1 violent atmospheric release every 11 days. This extreme regularity is not random. It acts as a diagnostic signal. It tells volcanologists that the primary geological conduit, the vertical pipe linking the deep mantle plume to the shallow magma reservoir just 1 to 3 kilometers below the caldera floor, is currently wide open. The mountain is breathing. But in atmospheric and geological tracking, true escalation rarely begins with an explosion. It begins with a microscopic anomaly in the baseline data. For episode 46, that warning signal was detected by the Uekahuna tilt meter. Tilt meters are highly sensitive instruments designed to measure microscopic deformations in the ground. They track the actual warping of the Earth's surface. Days before any visible lava appeared, the Uekahuna instrument began recording continuous silent inflationary tilt. The ground surrounding the caldera was physically bowing upward. Pressure was compounding in the shallow subterranean reservoir. Magma was rushing in, pushing against the rock from below. The tipping point arrived under the cover of darkness. At exactly 1:38 inches the morning on Monday, May 4th, the mounting subterranean pressure finally breached the surface. Lava began simply overflowing from the north vent inside Halemaumau. It was a slow, relatively quiet spillage. The dark crater floor began to glow, but mathematical models tracking the gas content of the magma indicated a rapid violent escalation was imminent. Magma is heavily saturated with dissolved gases, primarily water vapor, carbon dioxide, and sulfur dioxide. Under extreme pressure deep underground, these gases remain trapped in the liquid rock. But as the magma rises toward the surface, the confining pressure drops. The gases begin to exsolve. They form microscopic bubbles that rapidly expand. This chemical incubation turns a sluggish overflow into a pressurized bomb. Recognizing this shifting data, the U.S. Geological Survey acted quickly. By 1:50 p.m. that afternoon, they officially raised the volcano alert level from an advisory status to a formal watch. Simultaneously, they elevated the aviation color code from yellow to a warning orange. That aviation warning is critical. Volcanic ash is not like smoke from a wood fire. It is composed of microscopic jagged shards of glass and pulverized rock. If sucked into the intake of a commercial jet engine, the extreme heat melts the glass, fusing it to the turbine blades and causing catastrophic engine failure. The mountain was incubating. The alert was out. The clock was now ticking toward a massive kinetic release. 18 agonizing hours passed as the magma column swelled against the fractured bedrock of the north vent. The gas bubbles inside the liquid rock were multiplying and expanding, fighting for release. Then the system reached critical mass. At 8:17 inches the morning on Tuesday, May 5th, the sluggish overflow violently transitioned. It became an aggressive vertical fountain. The sheer kinetic energy of the release was staggering. By 10:30 a.m., the fountain hit its absolute peak. It tore through the morning sky, reaching an altitude of 650 feet or 200 meters above ground level. The atmospheric fallout was immediate. The massive thermal updraft generated a dense volcanic plume that pierced the troposphere, reaching 2,000 feet above sea level. High-altitude meteorological models captured initial winds blowing in from the southeast. This systematically distributed the hazardous material to the northwest. The sky darkened. Fist-sized lava clasts began raining down heavily on the Uekahuna Overlook parking area, located a quarter-mile away from the erupting vent. These clasts are aerodynamically shaped fragments of molten rock that cool as they fly through the air, hitting the ground with the force of falling bricks. Recognizing the immediate lethal threat, the National Park Service urgently closed a vulnerable section of the crater rim trail downwind. The communities of Volcano and Mountain View were placed under strict ashfall advisories as the atmospheric column began dropping microscopic glass fragments across residential rooftops and water catchments. To understand a shift this massive, the approach we take at American Sky Brief requires looking beneath the surface data. The national news networks predictably fixated on the spectacular 200-meter fountain. The USGS live streams captured the awe-inspiring event from 3 different angles. When the fountaining abruptly stopped at 5:22 in the afternoon, the official alert level was swiftly lowered back down to advisory status before sunset. By the agency's own structural classification, the eruption was technically over. The danger had passed. Here is the detail most reports missed. None of the 46 episodes recorded since December 2024 has been a complete eruption. They are pulses. Each spectacular fountain merely drains a tiny fraction of magma from the shallow reservoir. Every pause is simply the system straining to refill itself, and those subterranean refills are highly incomplete. This partial rhythmic draining is the actual mechanism we are tracking. Kilauea possesses 2 distinctly different eruption modes. The first is effusive. This is characterized by slow, ground-hugging lava flows that creep across the landscape at a walking speed. The decades-long Pu'u'o eruption demonstrated this perfectly. It quietly added 500 acres of brand new real estate to the island, while largely sparing human life, because the threat moves slowly. People can simply walk away. But the current episodic draining is tempting, the second vastly more dangerous mode, the phreatic or explosive eruption. A phreatic explosion does not require an influx of volatile new magma. It only requires the pre-existing magma to violently drain away. Current scientific hypotheses and historical precedents suggest that when the internal conduit inevitably closes, the system will be forced to shift. If the magma column drops deeply enough, it falls below the local water table. Millions of gallons of cold groundwater rush into the newly emptied voids. The water collides with rock superheated to over 1800 degrees Fahrenheit. The physics are absolute. The water flashes instantly to steam. It expands to 1600 times its original volume in a fraction of a second. That expansion generates a localized explosive force capable of tearing the mountain apart from the inside out. This specific mechanism birthed the nightmare of 1924. In a chilling parallel, that event began in February of that year when a massive lava lake that had churned inside Halemaumau for 2 decades suddenly disappeared. It drained completely down the East Rift Zone. The structural integrity of the entire region began to fail. In April, an aggressive earthquake swarm migrated away from the summit and down the rift. Ground cracking ripped open the earth in Kapoho 50 kilometers away. Large sections of the coastline physically sank 14 feet into the ocean. By May, with the magma gone, the water rushed in. Blocks of earth were hurled 2,000 feet into the air. Ash columns reached 4 miles high, blotting out the sun. Over the course of 13 days, the crater produced more than 50 separate massive explosions. The violent steam expansion was so severe, it doubled the diameter of Halemaumau from 1,400 feet to an immense 3,000 feet. The lava lake would not return for another 85 years. The human fallout was permanent. On the morning of the 18th of May, 1924, a man from a nearby sugar plantation deliberately slipped past the roadblocks established by the park superintendent. He carried a camera. He intended to photograph the crater in the deceptive lulls between explosions. He navigated to within 2,000 feet of the crater rim. Then the largest, most violent explosion of the entire sequence detonated. The blast hurled massive 8-ton boulders, a staggering 1,600 feet from the rim. The photographer was struck by a falling boulder and severely burned by cascading superheated ash. Rescuers reached him 20 minutes later, but he perished en route to the hospital. He remains the only directly documented fatality from a Kīlauea explosive eruption in over 2 centuries. We also have precise modern data on what happens when the shallow reservoir drains without triggering a steam explosion. In 2018, the lava lake once again drained completely down the East Rift Zone. The sudden catastrophic loss of internal hydraulic pressure caused the caldera floor to simply collapse upon itself. It dropped an astonishing 1,500 feet over the course of just 2 months. That collapse pulverized the bedrock. It left the current crater walls in a state of permanent geological instability. Therefore, episode 46 was not the primary threat. It was merely a safety valve. The actual danger lies in the invisible, fragile architectural voids these relentless episodes are leaving behind in the rock. As the dust settled on the evening of May 5th, the macrosystem immediately began its cyclical reset. The Uekahuna tiltmeter is already recording inflation again. Fresh magma is actively rushing back into the summit reservoir, forcing the ground to bulge once more. The volcano alert level sits quietly at advisory. The broader Big Island is simply preparing for the inevitable arrival of episode 47. The primary question in the geological community is not whether Kilauea will produce another fountaining episode. The brutal mathematics of the interval since December 2024 guarantee it. The system averages one major release every 11 days. 46 have already been executed with clockwork precision. We also know episode 46 was inherently safe in isolation. It was confined entirely to a closed area within Hawaii Volcanoes National Park. No residential homes were threatened. No one was hurt. The definitive question is whether this exhausting 7-month pattern of pulsing is quietly leaving the entire system in a highly compromised state. Each fountain drains a small amount of magma. Each refill falls slightly short. When the conduit eventually closes and the next major change in eruptive style occurs, what will it look like? Will it mirror the catastrophic caldera floor collapse of 2018, swallowing 1,500 feet of Earth? Or will it mirror the violent steam-driven devastation of 1,924? Current scientific models dictate that both scenarios are entirely possible. Both have already occurred within this exact same crater. Neither has been ruled out by the data. The physical scars of the worst-case scenario are not hidden. The massive 8-ton boulders ejected in 1924 are still scattered today in a silent half-mile ring around the Halemaumau crater. The man who died trying to photograph them never made it back to the road. His boulder remains. Thomas Jagger, the legendary founder of the Hawaiian Volcano Observatory, watched the 1,924 sequence unfold firsthand. He penned an assessment that still echoes through modern science. He wrote that the explosive eruption was merely an incident in the mechanism of engulfment. The mountain is still engulfing. The system is still going. The 46th episode cleanly ended at 5:22 in the afternoon. The 47th is currently pending. If this level of unvarnished chronological Earth analysis is worth telling, subscribe to American Sky Brief. We bypass the hype and we cover the real story beneath the data every single week.